IBM Power Systems virtual servers are located in the IBM data centers, distinct from the IBM cloud servers with their own separate networking and direct attached storage. The environment is in its own pod, and the internal networks are fenced off, but offer connectivity options to meet customer requirements like access to the public internet. This infrastructure design enables IBM Power Virtual Server to maintain key enterprise software certification and support as part of the Power VS architecture. The virtual servers, known as instances or logical partitions or LPARs or virtual machines, all run on IBM Power Systems hardware with the Power VM hypervisor. The key parameters for a Power VS instance are as follows. Instance name is the name that will appear in the IBM Cloud Portal under the list of instances within that service. Specify a name that is easily understood and recognized by you so that you can quickly pick it out from the list of instances associated with your account. Server placement group is another key parameter that provides control over the host or the server on which a new virtual machine is placed. Using server placement groups, high availability solutions can be created within a data center. Apply an affinity or anti-affinity policy to each VM instance within a server placement group. When setting a placement group with an affinity policy, all VMs in that placement group are launched on the same server. When setting a placement group with an anti-affinity policy, all VMs in that placement group are launched on different servers. You can learn more about the placement groups and what they offer in the documentation linked to this coursework. VM pinning policy controls the movement of VMs or virtual machines during disasters or other events that may lead to a restart of your VM. You can learn more about hard and soft pinning options in the coursework that is to follow. SSH keys are either a public or a private key pair, and it's required in order to access the instance over a remote connection. An SSH key must be created and loaded into the IBM Cloud Portal prior to creating your instance, and you can learn more about how to do that in the coursework that we have just ahead. Operating systems include things like AIX, IBM I, or Linux operating systems. Several Linux images are available specifically for servers that will run SAP, and we'll cover a little bit of AIX and IBM I in the steps ahead. OS images are another key parameter for our instances. Users have the ability to choose an operating system image from either the Power VS image catalog, or they can bring their own image to the environment. Each supported OS has specific sets of images in the Power VS catalog for supported OS versions. Each instance is provisioned with a boot volume using the storage tier selected at the time that you provision. Storage tiers, as just mentioned, are another key parameter for Power VS environments. Power VS supports both Tier 1 and Tier 3 storage. Tier 1 provides a maximum of 100 input and output operations per second, or IOPS, per gigabyte, while Tier 3 provides a maximum of 3 IOPS per gigabyte. For that reason, we only recommend Tier 3 storage for non-production workloads. Storage pool affinity is another key parameter that you must think through and decide ahead of time when provisioning. 3 storage pool affinity options are available for Power VS: Auto Select, Affinity, and Anti-Affinity. If you select the Affinity option, it requires that the boot volume be placed in the same pool as another existing instance or existing boot volume. The new storage volumes for the instance will be placed in the same storage pool where the Affinity object resides. The Anti-Affinity option specifies that a different pool should be used from that or another existing instance or any other existing boot volumes. Yet another variable for you to consider are the core types that you're going to use for your Power VS instance. Power VS supports shared uncapped, shared capped, and dedicated cores. Shared uncapped cores are shared, as you would expect, amongst other clients. Shared capped cores are shared, but the resources do not expand beyond what is requested at the time. Dedicated cores are allocated on a specific client basis and are not shared amongst other multi-tenant users in the environment. The number of cores is, of course, also a consideration. The option for the number of cores assigned to an instance depends on the type of core type that you selected earlier. Shared capped and unshared capped cores support 0.25 or quarter core increments in terms of how you can scale and grow these, while dedicated cores must be assigned a full core at a time. Note that the maximum number of cores will also depend on the machine type and the availability in the selected region and the location where you go to deploy your Power VS instance. The amount of memory is another consideration. PowerVS instances must be provisioned with a minimum of 2 gigabytes of random access memory, or RAM. The maximum number of memory depends again on the machine type and the availability in that selected location. If greater than 64 gigabyte RAM per core is specified, a higher price will be charged as an additional surplus on top of the per core rates that they would charge for IBM Cloud. You may also want to consider additional storage volumes. When provisioning a new instance for additional storage, a new day volume can be created or an existing volume can be attached. Any storage volume added at that time will be using the same storage tier as the boot volume that was specified when you provisioned the instance. Networking is yet another consideration. PowerVS instances will be attached to a private network by default, but can optionally be attached to a public one. Internet accessible networks are considered to be public. Private networks connect to an existing subnet or go to a subnet that had been previously created. In this chapter and the steps ahead, you'll view a Power Video instance being provisioned and replicate the steps taken yourself using a click-through guide demonstration. So with that, let's take a pause on the theory and the terminology and take a little bit of time for hands-on work.